Howdy, this is Diego Cansino for comprehensive video assignment number 3 over base and acid equilibrium. And let's get into the explanations. Okay, howdy. So just for clarification, anything in green text is there as a guidance for myself, and just anything that's like formulas or equations used to get the answers, but the actual answers are within the cyan text. So for number 1, it's asking to calculate the H3O concentration and the OH concentration and POH. So starting with the H3O concentration, well, we're given pH already, so we just have to use our conversion formulas. So to calculate the H3O concentration, we have to use 10 to the negative pH. So plugging that in, we get 6.31 times 10 to the negative 4 power. Finding the OH concentration, since we already found the proton concentration, now we just plug it in to the kW divided by proton concentration formula in order to find OH. So plug it in with the kW being 1 times 10 to the negative 14 divided by our proton concentration, and we get 1.58 times 10 to the negative 11 power for OH concentration. To find POH, we simply use a conversion of 14 minus pH. So plugging it in, we got 14 minus 3.20, we get 10.8. For number 2, it's asking for the pH value of the formic acid and the percentage dissociation. So to find the pH, we have to, since this is a weak acid, we're going to set up an ice table. And setting up that ice table, we eventually get that Ka equation where Ka equals to x squared divided by 0.16 minus x, which we can simplify into x squared divided by 0.16. And to solve that, we just get the square root of 0.16, which is our concentration, times our Ka. Once we get that value, we could plug it into negative log, and we get our pH, which is 2.27. To find the percentage dissociation, we have to do our proton concentration divided by our initial concentration to 100%. So plugging in our proton concentration and our initial of that 16, plugging that into and times 100%, we get 3.33%. Comparing the parts for question 3, the biggest difference is that the first one in part 1 is HCl, which is a strong acid, so it will dissociate completely, while the second acid in part 2, it's a weak acid, so it won't. You could see that the first one is going to dissociate 100% being HCl, but the second one, the percentage dissociation only shows 3.3%, which is a massive difference. So they're just one's strong, one's weak. For question 4, we're seeing what is the pH of the solution, giving the concentration of the NOH. So NOH is a strong base, which means it should dissociate completely. So since we're given the concentration of the OH, in order to get pH, we first have to convert it to POH. And in order to do that, we get the negative log of the OH concentration, which gives us our POH. And then from there, once we get our POH to convert to pH, we plug in that into negative log, and we get that. And so once you get the POH, you're able to use the equation of pH equals 14 minus the POH, and we get 14.08. For number 5, what is the pH of this solution? So this is giving us a weak base. Once again, we're going to have to set up an ice table. So like before, we're using that formula of x squared divided by the given concentration. Once you get the square root of the concentration times the Kb, we get this. We get 0.00145 of our OH concentration, and then from there we just plug it in to get POH. And once given POH, we could use our conversion factor to go to pH. So 14 minus our POH of 2.84, which equals 11.16. So what is the difference between the two bases in part 4 and 5? The biggest difference is that NOH is a strong base while NH3 is a weak base, and because of this, well, the stronger base will just create a higher pH, and it's just going to be more basic just because it's stronger. So it will completely dissociate, unlike the weak one. For 7, explain why the soap works against the fire ant bite. It works because since it's stated over here in question 2, that fire ants release an acid. So I assume that the soap is acting like a base, or it is a base, or it's basic. So applying that soap to the acidic bites, I believe that's how to put it. It will basically neutralize it. So there'll be less acid, it'll just get neutralized, and then that's why it starts to hurt less, because there's less acid affecting the bite area. And that would be it for the comprehensive assignment 3 on acid and base equilibrium version 1.